Hello everyone. Today we'll be discussing a new topic under image morphology named opening. Opening is a very important topic with respect to image morphology, and it simply means that we have to first perform erosion of the image, and then we'll be performing dilation of the outcome of this image. Now we need to understand first why do we do dilation. Now if you can see in this diagram, suppose this is a image of one circuit and this is one IC and this is another IC. Now if you can see in the diagram, then there is a false line forming in between them, and we need to remove this false line. So for this removal of false line, we would be using the concept of opening. Let us first understand that how do we convert this image into a matrix of ones and zeros. So as we can see in the image, I have again taken a 10 cross 10 matrix for our convenience of understanding, and I'll be laying this IC as this part. So this ones will represent this particular IC, and this ones would represent the second IC. The false line which is formed in between them is represented by this ones. Rest all of the pixel values would be zeros. So my input image would look something like this, wherein the dark portion I have represented as black color by pixel 0, and the bright portion I have represented by white color by pixel 1. Now we'll be using this structural element in order to perform dilation and erosion on this image. So as my opening says that I have to first perform erosion on my image, so what will I do is I will take up my structural element and I will place my seed pixel onto this image. Alright, so if you can see that if I place my image over here, none of the pixels are matching, and for erosions it is at most important that both the pixels should match. So in place of my seed pixel, I'll be placing a 0. Next, when I put my structural element on this location, again it will result into 0, and hence the entire row will transform into 0. Again, let us move to next row. Again, since only one of my pixels is matching, the entire row will be 0, because for erosion we need both the pixels of structuring element to meet with my image. Next, I'll be moving over here. It is not matching, but when I move it over here, both the pixels are matching, and hence in place of seed pixels I will place a 1. Similarly here, similarly over here. Again, if I come over here, they are not matching, they are not matching. Again they will match thrice, and again they won't match. So let us move to 4th row. Again the result will be same as the above. Fifth row, again the result will be same as above. But when I am moving to the false line part, which is over here it is not matching, over here it is entirely matching, entirely matching, entirely matching. But when I bring my structuring element over this location, only one pixel is matching and second one is not matching. So the false line part will be becoming 0, and rest everyone will remain same as the above term. Similarly, if I get my structuring element to the next row, again if you can see over here it is not matching. Match, 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 no match, no match, 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 match. So it will be representing the pixels somewhat like this. If I take my structuring element to the next row, over here it is not matching, over here also it is not matching, and so on. So the entire 3 rows would be filled with zeros now. So as you can see from the diagram, I have removed, this was my IC number 1, this was my IC number 2, and this was my false line. I have removed my false line from this. But if my task has been already been done, then why do I need to perform dilation after this? The reason is, if you look at your question, then how many rows do you have for one IC? It is 1, 2, 3, 4, 5, 6. 3 pixels in each column, so 18 pixels are representing your one IC. But over here if you see 1, 2, 3, 4, 5, 15 pixels are representing your one IC. So over here there are 18 pixels for one IC, but over here there are only 15 pixels for one IC. So there has been a reduction in the amount of pixels. Now if we need to restore the amount of pixels, what do we need to do? We need to increase the number of ones, and that can be done only via dilation. Now keep one thing in mind, students generally tend to make a mistake that they perform the dilation on the original image itself. But we need to understand this, that dilation is to be performed on eroded image, not the original image. So again you will be placing your structuring element on this image now, and not your original image. So please keep this in mind, that dilation has to be performed on eroded image and not your original image. So now you will be keeping your structuring element over here. Since for dilation the required condition is that only one of the pixels should match, and over here none of the pixels are matching, the entire first row would be comprising of zeros. Now if I move my pixel over here, none of the pixels are matching. If you keep your structuring element over here, one pixel is matching, so this will result into 1. Over here none of the pixels are matching, over here none of the pixels are matching. Again I see a match over here, I see a match over here, I see a match over here. So again third row, if I move to third row, over here there is no match, over here there is a match, 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 no match, no match, 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 match. So answer would be same even for my fourth row, even for my fifth row, and even for my sixth row. Answer will be same even for my seventh row. But if I move forward downstairs, then I see condition is failing, so it would be covered with all zeros. So as you can see from this diagram, how many pixels do I have? 1, 2, 3, 4, 5, 6. 6 rows and 3 columns. That would give me 18 pixels for one IC, which is same as my input one. So it is utmost important to perform dilation on an eroded image in order for getting my IC's size of the IC as it is, but erosion is to be done to remove this false line. Now, it is utmost important that you watch the previous video for a better understanding of erosion and dilation that has been already been uploaded to your Moodle accounts. So kindly refer that to get a better understanding of erosion and dilation, and then you can perform this technique. In the next video, we will be looking at another technique, which is closing. Thank you.